I'm John Dan of Cable Wireless, the security engineering. And rather than the topic of the talk is the security attacks and detection on OC12 and above backbones. Rather than the presentation, I hope this will come out as an introduction to discussions among operators, network operators in the audience and on stage. You're going to see a lot of question marks and a lot of things we don't know the answer. We may have the questions, but we don't have the answer. And hopefully there may be answers out there in the audience. And I'm going to talk about the problems we face. And then I'm going to talk about the solutions, if we can call them solutions we have. And then we'll try to see whether we can think of any possible solutions for the future. And the responsibility of our team is ensure the security of our backbone and and the security of our customers. And for people who don't know, we have multiple OC12 backbones, and I mean, even as between two pods, there are 6-fold or 8-fold of OC12s. We don't have an OC48 line yet because of availability of equipment. But OC48 will come up pretty soon. To present the problems, I went through a month's worth of incident report tickets. And these are mostly incident reports from our customers when they're under attack for security problems, or other network operators or other parties that they see that seems to be that attacks come from our address block. So you will have the what do I do? Okay. We'll have the two, that means going toward our address block, and from means attacks from our address block. Usually it could be our customers, that's in rare case, or our customer ISPs address book, our customer ISPs, customers, or customers. And usually most of these reports are done by human. So you have the reporters who have various knowledge or background. From one extreme, you have the other, which file a web-based report with very little information. Doesn't tell you much. That really works. And the last category is other, and others that it doesn't tell you anything. You don't even know what's going on. And I couldn't figure out, so I put them under others. And on the other extreme, you have people who are telling you that I send numerous frequent SNMP traffic and jamming up our T1 lines, and I'm under Smurf attack. And then you know that you're dealing with somebody who knows what they're talking about. And you'll see that in the first category, Smurf attack, is indeed that's very popular, still very popular these days. And SYN attack, still popular, and DOS attack. And the next category, the port scanning, address scanning, And login attempts, I'm putting them login to a lot of things in that category. That's a mistake. I'll try to do a better job next time. And the login attempts are actually generated from automated tools, automated alerts, and then most of the login attempts are targeted toward our network elements, and we have automated tools picking out the login attempts, frequent login attempts, and then I guess it's the NOG people, when they started alerts, before they forget about alerts, they put in a ticketing system so that the next shift can send a message out to the other party, to the originating party's network operators. And the next category is when somebody say that I'm on an attack, somebody really or believe that they've been hacked. The following that is a mail relay and spamming. We're not really responsible for spamming, especially when our customers use our address space or our dial-up customers do the spamming. That actually goes to abuse at cw.net. But we are responsible when our customers' mail servers being used as mail relay and hosts, and that's a type of denial of service attack, and that brings down their mail servers and bring down their T1 lines. And most of the attacks, except in the category of login attempts, they're all attacks against our customers or from our customers' address, from our address space being used by our customers. We're not really, we know very well how to protect our backbone elements. That's part of what we don't worry about. And the biggest part, the problem we fear most are the denial of service attacks. And in the past month or months, in particular, Smurf attacks. And that's it. You get into the situation that our customers' T1 lines are jammed, and they're paying per packet. That's really, really bad, and we got to do something about it. And we're not really. It seems that the government agencies are very paranoid about the infrastructure attacks. If you see the agenda that the scheduled FBI talk will be on the attacks on the infrastructure. And earlier this year, I had a chance to talk to a couple of NSA engineers or scientists or people. They essentially they think the biggest problem is the fiber infrastructure will be under attack. I just couldn't understand their rationale, what their fears. I think it was just hypothetical attacks. They're hypothesizing all different ways of injecting optical signal into the fibers, and then I'll say, if they go through the trouble of doing that, I'm from a very research community in the optical and semiconductor research. And I know that those things are very, very hard to do. And rather than going through all the trouble doing the optical injection, the easiest thing is just cut the damn fibers. And people know that around our office, the building, that the fibers are very well marked, and every 100 meters, there you'll see a MCI posting here underneath here, right here. You have fiber on it. cables under here. And the easiest thing is in the middle of the night to just pick up the fiber and cut it. And that's the easiest infrastructure attack.
But John,
Yes.
aren't they interested in injecting something that would be false into the fiber, something that could be misconstrued? Not just cutting off contact, not just cutting off connectivity, but injecting some sort of fake message like turn off your network because there's some kind of disaster.
Like, spamming, with false address.
Yeah.
With the SONET signaling, I don't think is that easy. SONET signaling would reject those signals first. It's like injecting into a TCP connection on the OC12 speed or above. It's not an easy job. You need to have all the equipment and all the equipment and expertise doing that. It's very much involved. And for cutting the fibers, you need a shovel and the pair of scissors or clippers. Very easy to do. Okay. Again, our biggest fear is the denial of service attacks. Probably I should pause here to see the other operators' experience, that what type of attacks they fear most or they see most. Go ahead, Howard.
Yeah, just
Okay. If nobody's taking on any question, I'll leave it to the end. Okay. I said that I made a mistake putting a lot of things in the middle, the category port scanning, and especially the very bad is mixing the login attempts against our network elements in there. And then I went to search through another population of alerts. This is a different population. That's a week worth of managed firewall alerts. These are the firewalls we manage for our customers, and they're especially the automated alerts are very good in picking out scans, and there are SNMPs trying to mapping your network, and also under other scans, there are SNMP scans trying to map your address space. In that week, it seems that there are way too many RPC, TCP, RPC scans. There got to be some known bug that happened to be discovered that week or the week before. I didn't really bother to find out exactly what it was. But that week, the RPC scanning was very active. And the next several things, NetBus, back office, AMAP, those things all geared toward taking control of the host, of the targeting host. They're very malicious in other words. And of course you have mail relay and spamming. These are basically give you an idea the problems, the type of problems we face, and the solutions we have. And right now, for alerts, we don't have alerts. That we know about these attacks. I'm talking about the denial of service attacks. We only know about the attacks after the damages already done. The T1 line is already jammed, and the customers come out and scream. That's the only situation we know. That's not good. And then for tracing and denial of service attacks, that they all involve address spoofing, source address spoofing, or some sort of address spoofing. very hard to trace. And we're using the dust tracker. And to stop attack is that we just set up filters and on the edge router, and that's the still is not perfect solution. Okay, the dust tracker, probably this I added yesterday the author of dust tracker. That was inherited from the NCR days. It was written by Wei Ting Chan, an excellent coder, excellent programmer. He wrote the majority of the tools that we got from the MCI days, and probably the dust tracker was in public domain, and the code was distributed. I'm not sure his name was even in the code, but I feel that he did a lot of work, but his name never really known to the outside people. He deserves recognition. It works this way. When we have denial of service attack, and you have attacker at the lower left corner, and the attacker would normally send denial of service attack packets to the victim with the source address faked as the other party. So how do you know where the packets actually come from? Usually the dust tracker, the way it works is that we first give its address of the edge office and the nearest to the victim. And then the dust tracker will log into that edge router and then install ACL and to match the attack packet pattern. And then put the router in debug mode and try to figure out which interface that the attack packets come from. And then figure out the next hop, and then do it hop by hop, just into the source to the attacker. And there are situations that and then they trace to the boundary of if the attacker is from our network, is on our network, we can trace to the real attacker. That's good. That's great. But most of the cases that it traces to the boundary with the other ISPs, and in that case, we just send messages to Unet to get an automated responses, or in other cases, some smaller or some other ISPs, you send out messages, you don't get anything. That's dust tracker. Dust tracker has problems. It will be difficult to work with Smurf attack. Smurf attack works this way. The attacker sends the initiating packets to what's called the amplifiers. The amplifiers are broadcasting networks. And so one initiating packet sends into the amplifier. All the hosts on the broadcasting network will respond. But the initiating packet has a source address faked to be the victim. So we'll have, say, 255 responding packets going toward the victim. And the victim's, the TM1 line is usually will be jammed, and we'll hear screaming. And so the way to trace it is to put to use a dust tracker to put the to launch the dust tracker on the edge router of the amplifier to trace back to the attacker. but very often that the victim is our customer, but the amplifier is outside of our network. We can't do anything about it. That's one problem of DOS tracker. The other problem is that we are deploying switch-based or packet forwarding-based routers, which don't allow ACLs to be installed, and we can't. The DOS tracker in the current form doesn't work, or won't work. So we're facing a lot of challenges. The possible solutions, and we know the problems. The biggest problem is the on-service attacks, and possible solutions. For prevention, that's a big unknown. And I know BDN people put ACLs on their edge routers and CP routers to prevent IP spoofing. That's a good thing, definitely a good thing. But we don't know about, our greatest fear is the administrative burden that put on us. I'm not sure whether there's any BDN people in the audience. I'd really like to know their experience on the administrative burden when you have to configure all the routers with ACLs. The next thing we think that there's a possibility we may be able to build some attack detection system to give us an alert before the damage is being done. There's a possibility of doing that, and we have an ongoing project working on that. And then the tracing capability, that actually is getting to be an unknown. And that when a DOS tracker doesn't work anymore, what's next? Next item is blocking. How do you stop the attacks? Stopping attacks that, of course, edge router ACLs still will work. Yeah, well, the edge router ACLs to block the attacks, we do it temporarily. When there's the attack, we put in an ACL to stop it, not to block the attack, so that our customers' tier 1 lines will still be alive. But even our backbone, the attacking packets are actually still traversing our backbone. Is actually we're eating the cost too. Is there any better way of doing that, or any way of doing that? Stop blocking the attack. Anything not as bad as that one we have. I really like to have people who can who tell us about their experiences. Okay. About attack detection, there are intrusion detection systems commercially available, but they are relying on sniffing the Ethernet 10/100 speed. But that's not what we're dealing with. That's not what we have. And for us, you have to deal with a high-speed network. You have to deal with a non-broadcast network. But there's hope. We know one vendor who are working on the intrusion detection, which is the vendor itself is has existing commercial intrusion detection system, intrusion detection software for regular Ethernet, but they're working on the gigabit Ethernet, gigabit version. That's hope. At least that means that they think they have a way to deal with a high bandwidth. And Most of these systems they run on general purpose computers, and you know the CPU they're in the hundreds of acres. So it's easy to probably is workable with the 100 megabit per second Ethernet, but gigabit per second Ethernet, that will be above the regular CPU. Then you need to come up with tricks dealing with a high speed. And also we know there's one vendor, switch vendor, is working on a project, or thinking about working on a project to meet law enforcement's demand or requirements to sniff the traffic, sniff the network, so they can split off, divert ATM PVC to a different location for analysis or whatever purpose. But we don't like doing that. The other possibility is there's a traffic monitoring system originally developed by VBNS. And VBNS was our research and development group, and in MCI days, that at least that functioned that way, and it was a great team of people. What they have is they use optical splitter, split off one beam of light, and one goes to the normal traffic, the other beam goes to the monitor. And right now it's OC12 speed, and OC48s, they're working on it, and that's something we're going to start with. We're going to build the security analysis on top of the traffic monitoring tool they have. There's some hope on the early alert, but still we're really behind. And right now there's only the OC12 card available, hardware available, but our backbone, the minimum is, I think, 6 OC12 lines. So we're very far behind, and very soon we're going to have OC48, and it's scary. We're not done yet. We're still under development, but we're already behind. And the other things that about prevention, about blocking, we really don't have many good solutions. Okay, I'd like to open up for discussion of questions and answers. Hopefully that all the questions I raised up here got answered in some way. And of course, your questions are welcome too. Oh, okay, Brian.
Is this working? Okay. You asked about BBN, or you mentioned BBN. So my name's Tony Tauber, and I made the post to NANOG some time ago, which has been kind of misquoted and misconstrued. Where customers ask for them,
get close, a little bit closer to the
closer.
Yeah.
Okay. Where customers ask for them, we will provide anti-spoofing filters outward. In a lot of other places where possible, we use Cisco's IP unicast reverse path verify, or whatever it is, feature with Ceph switching. So, you know, it does a route table lookup for incoming packets and matches the source address to, you know, checks the reverse path against the source address and drops them if they don't match. Is that clear? People familiar with that? You can't hear it? Sorry.
Yeah,
sounds loud to me.
Not toward me.
Oh,
so
it's not towards you.
Very
Okay.
difficult for me to hear.
So I encourage people to use that where they can, because it works pretty well for us. Obviously, for multi-homed address space, it doesn't do too well. You can't put it on interconnects, but we're with BGP customers.
What tool?
It's, I'll shout it to you. It's the Cisco IP Verify Unicast Reverse Path with Ceph switching. People heard about it, not heard about it?
No.
No?
I never heard of it. Yeah.
Some people nodding. Okay.
I'd like to learn to know about it.
All right. It's with Ceph switching. There's a feature. I mean, it's been around for months now, where you can. Excuse me. Many months.
Okay.
All right. Anyway, so, well, we've used it, and I can attest to the fact that it works well, and it's hasn't caused many problems. I mean, the administrative, if anything, just not remembering that a certain customer is multi-homed or bringing up a new connection so they are multi-homed, and now you have to turn it off, that kind of thing.
Okay. Yeah, I've never heard of it.
Never heard of it. Okay.
Yeah, I'd like to talk to you more
Okay, sure.
afterwards to learn what it is.
Okay.
Okay. Thank you.
The attacks that we found most damaging to our network was the Smurf amplifiers. That's what we almost see exclusively when we're doing our reporting. And the only thing we ever did that seemed to work for us, and I don't know how universal it would be just to filter everything that had a broadcast address on the edge routers on our egress points. Anything that was being sent to a broadcast address, inbound or outbound, just get dumped. And we would only do that for Class C boundaries, but that seemed to knock down 98% of the average Smurf attack type thing. And it only added like 1% to our CPU processor load to handle it at basically 35, 40 megabit constant sustained rate. So,
which operator? Which ISP?
that was with Vario.
Very okay.
But that's not universal across Vario. That was just our little section when we were trying to hold our water.
Yeah, I agree that the if you filter 90% of the geared toward the Class C broadcasting, that should reduce the 90% of the Smurf attacks. But our network people they're afraid of putting any ACL, any filtering on the any of the backbone routers, and that's the situation. Probably Andrea Smith can tell better why we're just not doing that because of load question, the fear of loading the routers. Okay, go ahead.
AboveNet actually had a customer that attracted about a gigabit a second of Smurf attack, and they took a very novel approach, which I'm not actually recommending that anyone do, but it's something to consider nonetheless. They actually took a look at the Smurf amplifiers that were smurfing them, and they set them up. Basically, they lined up all the firing squad in a circle, and they basically made all the Smurf amplifiers smurf each other, so that they were. Now, this is actually particularly interesting if you smurf with the source addresses of the broadcast, because you can actually sometimes set up a never-ending smurf. Or I guess an yes. But this might not be legal. But the claim would be that this was done in self-defense.
So you're saying to knock out the amplifiers first?
Right. Basically, he took about 20 megabits a second of outbound traffic, which is about what caused the gigabit a second, and basically he cut the total Smurf down to about 40 or 50 meg, which, I mean, you had 100 meg connections, so it was livable from a gigabit a second by basically making them smurf each other. And he could have tried it even faster if he wanted to, but...
Well, isn't this similar to the NATO's tactic to knock out the fuel supplies of the Yugoslavia, Serbian...
I just thought it was really elegant, so...
Okay.
I posted some software to do some net flow analysis to look for Smurf attacks, which I have running on my network all the time. And I would see a lot of amplifier sites that I would detect, and I would send them email reporting that their networks were vulnerable. And it seems to be somewhat effective because I have lost a lot of the traffic that used to be hammering my network. An extreme solution is to route those networks to div null if they're non-responsive to requests to solve those problems.
What software do we use?
Wall-proof software.
Okay.
It's basically a modification to Cisco's software that they wrote to demonstrate net flow dumping, and you just look for self-similar data. I'm not a software programmer, so it wasn't particularly sophisticated software that I wrote.
Is it something installed on the routers, or?
You put it on a Unix host,
Okay.
and you tell a Cisco router to dump NetFlow data to a Unix machine, which then analyzes the data. And this only works at the lower speed, T3. I'm not sure, maybe OC3 would work as well. But at those speeds, on the edge 7500 routers, you can get NetFlow data and get that kind of information. It's pretty helpful.
Do you know whether the net flow capability will be there for the GSR, the switch-based routers?
I have not heard any firm commitments from Cisco to do that on the GSR.
Okay.
Has anybody else heard anything to that end, one way or the other?
Yeah, the GSR, the switch-based routers, that a lot of the packets won't go through the CPU anymore. It's very hard to do to insert any intelligence in the routers from this point.
I asked Cisco specifically about the NetFlow stats for the GSR, and they claim that they will be giving a subset of NetFlow. Not the full data per session, but you'll get things like source and destination IP, source and destination AS. I don't have a date or anything like that, but you will be getting NetFlow type stats, just not the full NetFlow data, because it is silicon based, a little more switch based, and they don't do as much lookup through the main CPU, but you'll get some data.
That'll help.
Yeah, thanks. Okay. Thank you very much.
Any more questions?
Thank you.